In this question, we're given the layout of a city with land masses and bridges, and we want to determine if it is possible for city residents to walk across all of the bridges without crossing the same bridge twice. So what I'm going to do is make a graph for this problem. So I'm going to have a vertex for bank B. I'm going to have one for island A, a vertex for island C, and a vertex for bank D. And there is one bridge going from A to B. We've got a bridge going from A to C and a bridge going from A to D. And then we have two bridges going from B to C. So we need two separate edges for that. And a bridge from C to D. So now I have a graph that represents this situation, and I can find the degree of every vertex. So vertex A has degree 3 because there are 3 edges coming out of that vertex. Vertex B also has degree 3 because, again, 1, 2, 3. And I like to mark the edges, and then especially when you have more edges coming out of a vertex, it helps to keep track of them. Vertex C has degree 1, 2, 3, 4. And D has degree 2. So that tells me that there is an Euler path, and it has to start at either vertex A or vertex B and end at the other one. So it says, is it possible for city residents to walk across all of the bridges without crossing the same bridge twice? Yes, because I could go from A to D, from D to C, from C to A to B, B to C, and then finally C back to B. So you can see where you start at A, you can end at B. If you go in the reverse order, you could start at B and end at A. So my answer is yes, it is possible to do that. And where should they begin? Where should they end? They could start at B and end at A, and they don't give me an option for the opposite, so that's the only correct answer choice. And that's how you do that problem.